All right. So I'm starting the recorder and just get started. I know people are kind of still streaming in. There should be about almost twice as many students. But I'm going to get started anyway. And okay, are you ready? Okay.
Want to pass the roll sheet around?
We'll pass the roll sheet in about 15 minutes or so, just so that people have a little bit more time to stream in. Well, this is not high school. I'm not gonna make people have a tardy stamp to stamp on people, right? Okay, last time on Tuesday, we talked about the while loop, or what they call a pre-checking loop. This is what I call a post-checking loop. So as the name implies, it implies that we check the condition after an action is taken instead of before an action is taken. Okay, so we'll go ahead and take a look at the picture first, because I think the picture is a little bit more useful than the pseudocode, at least when we first encounter the concept. So this is the picture of the logic, a picture that represents the logic of a post-checking loop instead of a pre-checking loop. So what we do is we are still coming in from the north. Okay? We're still going in the south direction. But the first thing we do is not to make a decision. The first thing we do is to go straight into the action specified between the repeat and the until words. Whatever, you can have one line in between, you can have 20 lines in between, you can have even more lines in between. So it doesn't matter how many lines are between the repeat and the until. We perform that operation first. We perform that sequence of operation if there are more than one. And then when we get out of those actions, then we make a decision. We ask a question, okay, whatever the condition is, we ask the question. Now this is the part that makes it a little bit different from a while do loop also, is we take a branch all the way back to the beginning if and only if the answer is false. Okay, in other words, we perform another iteration if the condition is false. If the condition is true, then we move on to whatever statement is following this one. So that's why this condition is also called a terminating condition or exit condition, because when this condition is true, we get out of the loop. We stop the repetition. Are we doing okay so far with this concept? So in a way, it is related to a pre-checking loop because they are both mechanisms where you can perform an action again and again. But they're different. A while loop and a repeat loop are different in two ways. One has to do with when do we evaluate the condition, and the second one has to do with when do we get out of the loop based on the result of the condition. So those two are different depending on which loop we are using. Are there any questions about this picture, or what the logic that is represented by this picture here? Go ahead.
So I'm kind of having trouble. Is this different than a while loop, or is this basically?
This is a different loop. This is a different kind of loop. It is related to a while loop because they're both repetitions or iterative statements. But this one is different because you can see that the condition is evaluated after we perform an action, whereas before we ask the question before we perform the action. So they are they're similar in the from the perspective of they both can do repetition. But they're different from the perspective of, can we skip the very first iteration? With a pre-checking loop, sometimes you don't even perform one single iteration. With this one, you always perform at least one iteration because you're asking the question whether we should get out or not after you perform the first iteration. Now, in general, in most programming situations, this is actually the rare one. Okay, this is the one that we seldom use. But there are situations where this one makes more sense. Okay, so I'm going to give you a particular situation where this makes more sense than the other loop. So the situation when a post-checking loop or repeat until loop makes more sense is when the condition itself cannot be evaluated until you have at least one iteration through. In other words, the body of the loop is going to set up the condition that you really need to evaluate. And I'll give you this example here. So let's think about a program that keeps prompting a user for a zip code until the zip code is validated. Okay, and right here, we are not even that concerned about how do we express that the zip code is valid, or how do we ask an end user for a zip code. It can be a dialog box, can be a text-based program just prompting the user on the command line. So that part we're not too concerned. But what we are concerned about is the logic. So the logic would go like this: repeat ask end user to enter a zip code until the zip code is valid. Okay, so if you just kind of read this as English, it seems to make sense, right? Repeat ask end user to enter a zip code until the zip code is valid. In other words, if the user enters something that is invalid, I want to ask the user to enter again. Okay, I'm not even specifying the logic to print an error message, a warning message, and stuff like that. I'm just focusing on the main logic of the loop here. Now, in this case, a repeat until loop makes a whole lot more sense than a while loop, because the condition, which is quote unquote the zip code is valid, cannot be evaluated until the user has entered something. So I can't really ask that question. I cannot evaluate that condition before the action, before asking the end user to enter a zip code. Okay? In other words, if I were to rewrite this as a while loop, which means it is going to be while the zip code is invalid, remember, because this has to do with the polarity of the logic. In a while loop, we get out of the loop when the condition is false. Okay? So if it is false that the zip code is invalid, it means it is invalid, right? Because it's double negation. So that's why we have to negate it here first, and then we say ask end user to enter a zip code and while. So if you compare these two loops, the second one doesn't make sense, because when we first get into this logic the first time, what zip code am I trying to validate? It's whatever it was, uninitialized, right? It's not the one that the user enters. Okay, so that's why in this particular situation, a repeat until loop makes more sense than a while loop. Now there are ways to fix a while loop so that we can accomplish about the same thing. One way to do it, which is definitely not a very good approach, is to copy and paste ask end user to enter zip code, so that we definitely ask it first before we get into the while loop, so that we can accomplish the same effect as the repeat until loop. Now, why is it not a good approach? Because every time you use the copy and paste approach in programming, you really have to ask yourself, is there a better way to do it? Copy and paste generally tells you that, maybe there's a better way to do it. And I just did a copy and paste, okay? So the better way to do this is to use a repeat until loop so that I do not have to copy and paste. Now, copy and paste may not seem like a problem because, hey, it's just one line of code. What is the problem? Well, what if the body of the loop has 20 lines, 30 lines, 50 lines? Okay, then you have to copy and paste all your 50 lines so that you have another copy, a clone of that code before the while loop. Now, why is that a problem? Well, it does make your program longer, which is not really the main problem. The main problem has to do with what if you have 5 bugs within those 50 lines of code? Well, eventually you will find and fix those bugs, right? But will you remember to fix both copies of that code? Because now you have 2 copies of the same code, and when you fix it, you probably have to fix both versions or both copies of that code. And that's the reason why copying and pasting is not a good idea, because it makes debugging your program more difficult. Having only one single copy of any logic helps to contain bugs. Basically, there's only one copy, so if you find a bug, you fix it, you're done. You don't have to worry, oh, do I have 20 copies of the same code sitting somewhere else in the program? So are there any questions about why in this case the repeat until loop makes more sense than the while do loop? If there are no questions, then we're going to go take a look at several examples, okay, just so that we can contrast and compare the 2 kinds of loops. So we'll go into LibreOffice. check out the logic. Now, when I write these sample code and go through the traces, I really do not expect you guys to copy and write down everything, because that's just going to be using a lot of your time. But at the same time, I don't want you guys to be just sitting there listening to me either. So you want to kind of write down the important parts of the discussion, okay? Things that really kind of stand out, so that when you read your own notes, you're basically reading the part that is kind of important, and all the detail you can just watch YouTube again. All right, so we'll go ahead and take a look at this example here, which by itself is already a slightly trickier case. Okay, so we'll start with x gets a value of 30, and then we'll say while x is less than 5, okay, to make it very, very contrasting here. While x is less than 5, x gets x plus 1, and while. Okay, so we'll change the indentation a little bit. And then we'll use another window to do the trace. Uh-oh, it just got out of the screen because I was using a screen that was bigger than this one. So do this, put it back on the screen, and open a new sheet for tracing it. To trace a loop or anything that has conditional statements or loops, I need a column for comments, because I need to know, when I get to line 2. When I get to line 2, I have 2 places to go after line 2. I can either go to line 3 because the condition is true, or I can go to post, in this case, when the condition is false. So I have to use the comments column to record why I made the decision to go one way or the other, and that's why the comments column is important. Then we have the usual line number and x here. X is going to start with an unknown value, because even if I give it a known value to begin with, it doesn't really matter, because the first thing we do on line 1 is to overwrite that value with 30. So that's why as a precondition, there's no need to initialize x to any particular value. On line 1, x is now initialized to 30. We get to line 2, and the first thing we do on line 2 is to evaluate the condition. The condition is asking x is less than 5. Is it true or is it false? False. It's false. Okay, so x is less than 5 is false. So where do we go?
Post.
We go to post. Excellent. Okay, that's exactly the behavior of this program, is we don't even increment x by 1 even once, because the condition is the guard. Okay, we check it before the action. So if the condition is false to begin with, even before the first iteration, then we still have to skip over the entire loop and then get to the next statement. But since in this case we don't have a next statement, we exit the program entirely. Are we doing okay with this case? Okay. If this is okay, then we're going to move on to a similar program, but using a RepeatUntil Look instead. So let me just kind of resize this again, because vertically it is still at the wrong size. Okay, I'm going to make an exception here, not open a new document. So we'll go ahead and just sheet 3 of this same spreadsheet here, and this time we'll have about the same thing. Okay, x gets initialized to 30, but this time we use repeat. Okay, repeat x gets x plus 1 until x is greater than or equal to 5, which is the negation of the logic of x is less than 5. Because remember, when we specify a post-checking loop, we are specifying when are we getting out of the loop instead of when are we staying in the loop. All right. Is that kind of consistent with the usual use of repeat until? When you tell somebody to repeat doing something or just do something until da da da, that until da 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 is the exit condition, right? You cannot watch TV and keep doing your homework until your homework is all done. Well, homework is all done is our condition. And you can only get out of that quote-unquote loop after your homework is done, right? So this is actually consistent with the way we use the word until in a natural setting. What about while? How many people use the word while on a regular basis, just in normal conversation? Some, it's not common, okay? We do have a phrase that means exactly the same thing as while, but we use that phrase a lot more often, as long as. Okay? As long as you haven't found a parking spot, keep circling around in the parking lot. Okay? Same thing as a while. All right, so let's go ahead and take a look at this one. And we'll go ahead and trace it again, and this time we'll trace it in sheet 4. Same thing, we need a column for comments, one column for line number, and one column for X. X can start with an unknown value because line 1 is going to initialize it. So on line 1, once again, we just initialize X to 30. And I have no idea why this time it doesn't have enough width, but last time it did. Okay, we do not trace line 2, okay? Line 2 by itself doesn't do a single thing. Its only job is syntactically here to help us identify, okay, where's the beginning of the post-checking loop and where's the until help us understand where's the end of the post-checking loop. So we don't really trace it because it doesn't really do anything. So the first line we get to is actually line 3 in this case. We don't have a choice because the condition is evaluated after line 3. So we do have to get to line 3, even though it seems kind of awkward, right? I want to repeat blah, blah, blah until X is greater than or equal to 5, but X is already greater than or equal to 5. Well, it doesn't help in this case. You have to perform the action specified between repeat and until. So X actually gets incremented to 31 because of line 3, and then we get to line 4. On line 4, X equals to 5, X is greater than or equal to 5 is true, and at that point we can get out of the loop and get to post. So we can see the behavior of the two loops are different, okay? The first one skips the entire thing the first time. It doesn't do any type of incrementing. The second one, on the other hand, does not have a choice. It has to execute line 3 first, and then it evaluates the condition and say, oh, okay, I guess I can leave now. Okay. Do you think the end result doesn't seem to be that important? X is now 31 instead of 30. So, but is that important when you're writing a program, when the numbers are just off by 1?
Yeah.
Oh, yeah. That really can mean whether your program is working correctly or not, whether it will crash later on or not, and so on. Okay. For those of you who will eventually move on to cisp300, which is the assembly language programming class, in that class we'll start to talk about concepts where just incrementing one too many times can lead to a program just crashing, hard crashing. It just stops working altogether. Yep.
Is that like an index out of bound?
It's index out of bound, but it has to do with the array is up against some other really important items. So when you override that really important item, the program or it has to do with subroutines too, and a few other things that we are not going to talk about in this class. But the problem is, because of memory corruption and incrementing a number just one beyond what it's supposed to be can lead to those problems. All right, so this is all done. Are there any questions about pre-checking loops versus post-checking loops? Questions? Okay. Now I just realized one thing. Okay, I kind of use the word if in this class, not in the sense of conditional statements, just in general. Sometimes I use it incorrectly. Okay, most of the time I use it correctly, but sometimes I use it incorrectly. So I do want to spend just a little bit of time to talk about the word if and phrases related to if. Okay, so in normal English usage, okay, we have the word if, we have the phrase only if, and very seldom, unless you're in a math class, you have if and only if. Okay, so these are the three things that we usually encounter in a conversation. How many people use the word if or unless? Because that's just an negation if. How about only if as a phrase? Okay, sometimes. What about if and only if? Almost none, right? Okay. So I do want to talk about these three terms because we use these words kind of loosely in a colloquial way, but they really have specific meanings when it comes to mathematics and also programming. So I want to kind of talk about this a little bit, but not kind of in a dry mathematical way because I will leave that to your math professor. I mean, that's their job. My job is to connect these concepts to programming. So what I'll do is I'm going to say, make a statement, okay? So let's just say that as a class, you guys pony up $50, and then you say, okay, Tech, give us a statement, for $50. Give me a statement that is true, okay? Whatever statement. So I'm going to give you something for $50. I would say if the, okay, I'm going to leave space here so I don't have to resize the columns later. If the sky is orange, then everyone will fail cisp 300. That's my statement. You pay me $50 and I tell you something like this. Okay? You're not quite happy with this statement, you go like, and you're thinking, when can I get my $50 back? Okay, because I just paid $50 for a stupid statement like this, right? So you want to get your $50 back, but you can only get the $50 back according to my my money back warranty if you can prove my statement to be wrong. Okay, if you can prove my statement to be wrong, I'll give you $60 back, not just your money back, but have $10 on top of that. Is that okay so far? Okay, so let's say this is the statement that I gave you, and then you have to give me a scenario, right? There will be a particular scenario, maybe, in which you can get your money back. So we'll go over the 4 possible scenarios. In other words, I'm going to say true, 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 false, false, true, and false, false. In other words, if you look at the sky is orange, it really is a condition. Okay, I'm not saying the sky is orange today. If the sky is orange, is really a question. Okay, the sky being orange is a question. Is the sky orange? Is it true or false that the sky is orange? So it really is a question. It's not a statement saying that it is true. Same thing with everybody failing cisp 300. Okay, it's a condition. Okay, it can be true, it can be false. So that's why we have what we call a truth table here to represent the 4 possible scenarios. Okay, the first one means we can observe at least once that the sky is orange, and the second part of that is everybody is failing cisp 300. The second one, the second row is saying I can observe at least once that the sky is orange, but at least one person passed cisp 300 with a C or better, and so on. But you can see that there are only 4 possible combinations because each condition can either be true or false, right? Boolean, okay? It's one or the other. But the 2 conditions are independent, okay? Or at least, I'm assuming they are independent. So as a result, when the first one is true, the second one can be true or false. When the first one is false, the second one can be true or false. So that gives me a 4 possible combination. Is that okay so far? Okay. So now, because this is already listing all the possible cases, now I can say, can you get your money back? In other words, I'm asking, is the statement itself, if the sky is orange, then everybody will fail cisp 300. Is that statement true or false? If what you're observing is the sky being orange and everybody is failing cisp 300. So what do you think? Well, this one is true because if the statement states if the sky is orange, then everybody will fail cisp 300, and you observe, okay, the sky is in fact orange, and everybody is failing cisp 300. That just proves that my statement is true. It is not proving it is wrong. Okay?
This goes back to what you said the other day. Would it be true for the first one, and then the rest would be false?
Ah, that would be the question, right? Okay, so the next line, okay, the next row is here. For the entire semester, we cannot observe a single day where the sky is orange. And then at the end, I take it back. Okay. For the entire semester, we observe the sky is orange at least once. Okay. So the first part of the if statement is true. And at the end of the semester, at least one person, passes the class. So is the entire statement true or false?
False.
It's false, you can get your money back, right? You can get your $60 back. So you have $10 extra to buy, Starbucks coffee or something for the entire class. Okay, that one is kind of easy, right? The second row is pretty easy. The third row and the fourth row are the tricky ones. Okay, so what it is my statement is still the same. Okay, you pay $50, and I'm still saying, okay, if the sky is orange, then everybody will fail cisp300. But what we are observing is not a single day that the sky is orange. Okay, so the first condition is actually false, and everybody is failing cisp300 anyway. So in that case, can you say that my original statement, the entire statement, is true and you cannot get your money back? Or can you say that the entire statement is false and you get your $60? That really is the question.
False.
Okay, true. Huh?
You can't really say it's either because the statement never happened.
Because
You never got to test the statement. There was no orange days, so the statement was never.
so my statement is still true.
It could be true. It's kind of like unproven.
Well, in mathematics, in logic, my statement is still true. Because my statement never said anything about what if the sky is not orange. Okay? So in the case of the sky not being orange, my statement is still not proven to be false. Is that okay? It's a little bit awkward, right? You can also apply this to a normal, daily situation. Okay, I just got a Toyota recall, letter. Basically, it says, okay, on some cars, okay, this particular switch can be ignition switch. I cannot remember which one can be installed incorrectly. So what it says is, if your car has problems with, starting and whatnot, then you can bring the car into the Toyota dealership and we'll fix it. Okay, that's what Toyota promises. If your car has a problem with that ignition, then you can bring it in and we'll fix it under extended warranty. Okay, because it's our fault to put in faulty components, so we'll handle it. Okay, so once again we have the word if. Let's say my car does have that problem. So the first condition is true. I bring it into Toyota, and Toyota says, no, we're not going to fix it. Do you think I have a reason to be a little bit, upset? Sure, because they did not do what they promised to do, right? If I have a problem, with my ignition, I bring my car into the dealership and say, fine, we'll fix it according to the contract. It's good. So the big question is, what if I don't have a problem with that ignition switch? According to the warranty or the extended warranty service, whatever you call it a recall letter. According to the recall letter, does Toyota have to do anything? Nope, because they didn't say what needs to happen when the ignition switch does not have a problem. So it's the same thing here. So when in this particular statement, if the sky is not orange, then whatever I say in this statement is still true, because I didn't say a single thing about what happens when the sky is not orange. Okay? And that's how mathematicians look at the word if. And obviously the last one is true. The statement is true also when what you observe is the sky is not orange a single time, and at least one person passes a cisp300. Now, there's another way to say something like this. The other way to say this is to say the sky is orange, and I'm going to use quotes here just so that we can separate the conditions from the other words here. I can say this is sufficient, is a sufficient condition for. The other one is everyone will fail, or everyone failing CISP 300. In other words, the word if means exactly the same thing as a sufficient condition. The first one is a sufficient condition for the second one. Are we still doing okay so far? In mathematics, can someone give me a condition that is a sufficient condition for another one? Let me just give you an example here. So I will say x is greater than y is the first one. So x is greater than y is a sufficient condition for what else? In other words, what does it imply? I mean, it does imply itself, but that would not be very interesting.
The y is less than x.
The y is less than x, but that's the same thing as itself. I'm just, you're just reversing it. That would be true, but there's a better way to describe, that one. What about x is not the same as y? Does that make any sense to you? Yeah. If I tell you ahead of time and say, okay, I'm giving you this value of x and this value of y, and I'm telling you x is greater than y, does that guarantee that x is different from y? Yep, it does. So in that case, x is greater than y is a sufficient condition for the other one, which is x is different from y. Okay. So now let's move on to the next, phrase. Only if the sky is orange, then everyone will fail CISP 300. So let's see, when you can get your money back. You can see the odds are really kind of against you. Okay, so we'll go ahead and remove every single one here, and then we'll evaluate each and every single one. So the statement is now saying, only if the sky is orange, then everybody will fail CISP 300. Throughout this semester, we observe at least once the sky being orange. And at the end of the semester, everybody fails CISP 300, this class. So is my statement true or false in this case?
False.
True. Only if the sky is orange, then everybody will fail CISP 300, but we observe the sky being orange at least once, and everybody does fail CISP 300 at the end, so the statement is true, okay? Okay. The second one becomes a tricky one, because the second one says, well, the statement is still the same, only if the sky is orange, then everybody will fail CISP 300. But what we observe is at least one day the sky is orange. But at the end of the semester, somebody passes CISP 300. So the question now is my statement still true or false? Can you get your $60?
False.
It's true. Okay. Now, why is that? Sorry?
Never mind, go ahead.
No, go ahead.
I just was saying, can you explain that?
Yes, absolutely. Because when we use the word only if, it means it becomes a necessary condition instead of a sufficient condition. Okay? Now, what is the difference between sufficient versus necessary?
Well, necessary condition, that condition has to occur at least once in order for this to be evaluated, I think.
You mean in the second one?
Yeah, the second one.
In the second one, it means everybody failing CISP 300 requires the sky being orange. Now there may be some other factors contributing to everybody failing CISP 300, but the sky being orange is a necessary condition for that to happen. Which means if the sky is not orange, then we would have failed to meet one of the required conditions for everybody to fail the class. That's basically what it's saying. Yep, go ahead.
I was just going to say that.
Okay.
But what about the word everyone?
Everyone?
That's what kind of gets me, is that you said, well, one person passed.
Okay, what about, I can easily rewrite this portion. So instead of using, okay, let me just copy and paste it, because I want to keep the original one too. Okay, how about this one? No one will pass CISP 300. which means exactly the same thing from the
Right.
logic perspective.
Right, but I'm just trying to figure out why it's true if one person passed. If no one and everyone was supposed to fail, but one person passed, then how is it true?
Okay, if the statement is no one will pass cisp300, but at least one person is passing, that means that condition is false. Only this part is false. Okay, if the statement or if the condition is no one will pass, but at least one person is passing, that means this portion of the condition is false. It's not saying that the entire thing is false. Okay, it's not saying the conditional statement itself is false. It's just saying one part of it is false. Okay. Excuse me.
So, are you saying that in this situation, the student could not get their money back only for the fact that the sky was orange at least once and you therefore met your portion of it and the rest of it because it's not the necessary part of the condition?
You're not getting any money back, because the sky being orange is now a necessary condition, but there may be some other conditions that combined, will make the entire class, fail.
The sky being orange is the only one that's considered necessary, is that right? Or are they, are both?
In this statement, it is saying that the sky is orange is at least one of the many, potentially many necessary conditions. It doesn't say a single thing about whether there are other necessary conditions. It is simply saying that the sky being orange is at least one of the many necessary conditions in order for the entire class to fail. So if you meet one of the many necessary conditions, it does not necessarily guarantee the other condition will be true. Go ahead.
Doesn't that mean that the sky has to always be orange?
No, the sky being is orange, or we can change that phrase to the sky, is observed to be orange at least once during the semester. I mean, we can make it more specific. But the whole point is, if the sky is orange, then if the first condition is true, it is only saying that we have at least one of the potentially many necessary conditions guaranteed, but it doesn't guarantee the end result will happen because there can be other conditions leading that are also necessary. Yep.
So how does a necessary condition affect the statement's overall true or falseness? Because I don't really quite know what that connection.
It has to do with the other two. Okay, so let's finish the 4 rows first, and then it will become kind of more clear as to when you can get your money back. Okay, in fact, this one is gonna do the trick. Okay, this row, which is the 3rd row, says okay, for the entire semester we cannot even observe once that the sky is orange. Okay, it has been overcast or blue or black. Okay, at night, and we observe that everybody is failing cisp300. Okay. So the question is, can you get your money back?
Yes.
Yes.
You can get your money back because in that case, because I claim that the sky is orange is a necessary condition for the entire class to fail. But yet, this condition is not met, and yet the end result happens. So that's the only case where you can get your money back because my statement is false. And the last one, you cannot get your money back because we observe the sky is blue, overcast, or black the entire semester, and almost the entire class passed cisp300. You cannot get your money back. Okay, so now we'll go ahead and look at this statement again, but this time we'll look at it from the perspective of necessary versus sufficient. So this time we are basically saying the sky is orange is a necessary condition for everyone failing cisp300. And here, once again, we are using the word necessary instead of sufficient. And basically, if I say something is necessary for something else to happen, it's not saying that it is the only necessary condition. It's simply saying that this can be one of many necessary conditions. So but on the other hand, if I fail to meet at least one of the necessary conditions, the other part should not happen. Is that okay so far? Kind of? Okay. So let's go back and use mathematical notations just just to connect this concept here. So this time, if I say x is different from y, is a necessary condition for, well, I'll let you guys fill in the blank. X is not the same as y is necessary in order for, there are at least two possible answers here.
X less than y is greater than y.
Exactly. Okay, but we can just pick one. Okay, so I'm going to pick the one that we have used before, which is x is greater than y. Does it make any sense? In order for x to be greater than y, this condition that x is not the same as y needs to be guaranteed first. Makes sense. Okay. Now, let me just go back and give you another way to express exactly the same thing. Sometimes it leads to more confusion, and other times it helps. Because the other way to say this is implies. X is greater than y implies x is different from y. That's the same thing as saying if x is greater than y, then x is different from y. The other one, this one here, is almost the same, but it's reversed. X is not the same as y is implied by x is greater than y. Is that making any sense to you? The imply versus implied by. Are we doing okay so far with this slide up to this point? Okay. So now we move on to the last one, which is the one that we don't use in normal English. The one that we don't use in normal English is this one. So let me just copy and paste it. This one says, if and only if. Right, so finally we move on to the one that I really want to get to. Okay. So with this one here, if the statement is saying if and only if the sky is orange, then everyone will fail cisp300. The other way to look at this is to say the sky is orange is both necessary and sufficient for everybody to fail cisp300. Okay? So in that case, if what we observe is, okay, the sky is observed, orange at least once, and everybody is failing the class, can you get your money back? No. No, you cannot get your money back because the statement itself is true. What about the second case? The sky is orange, or at least observed to be orange at least once, and somebody passes the class.
Yes.
Can you get your money back?
Yes.
Yeah, absolutely. You can get your money back because the statement as a whole is false. What about the third one? The sky has not been orange once for the entire semester, and not a single person in this class is passing.
No.
Can you get your money back?
No.
Yes.
You can't get your money back because the statement is false. Because the statement says if and only if the sky is orange, then everybody will fail cisp300. And once again, it means it is both a sufficient and necessary condition. So that means if you fail, if the first condition is true, it should guarantee the second condition, and vice versa. Okay? And vice versa. Okay, the last one, you cannot get your money back because we failed one, the other one should automatically fail. And it doesn't matter which one, it goes in both directions. Okay? So now, if I use the other terminology, it means, okay, I'm just going to copy this part here. And what it means is the sky is orange is in this case a necessary and sufficient condition for everybody failing cisp300. That's the other way to basically say the same thing without using if and only if. Now, what if we want to use this in an expression, comparison expression here? So let's try, x is different from y. Okay, once again we are using x is different from y, And this time we want it to be is a necessary and sufficient condition for fill in the blank. So this time we are basically saying if x is in fact different from y, the other one has to be true. If x is different from y is false, the other one has to be false. Okay, so this time is a lot more restrictive. We are basically saying what is another way of saying x is different from y, because we are looking for something that is equivalent to. So what is the other way to say that x is different from y?
X is greater or less than or equal.
Yep. Oops, you guys cannot see it because I forgot to change the refresh setting of the display. Just hold on 1 second. Let me fix this. There we go. Okay. What is the other way? I mean, necessary and sufficient is kind of a long phrase to use. There's another way to say this without using implied, but we can say it's implying and also implied by. But the other way to say it is to say this is, nope, it is equivalent to x is less than y or x is greater than y. So equivalent to is the other way to say the same thing. Because they're truly the same thing. We're just re-expressing it the same, different. Are we still doing okay so far? Now, why do you think this stuff is important? Seems like it's only important when we go to a philosophy class, right?
Or maybe it's important because, like, when you're doing a program, you want it to do this, if this, only if this.
We have conditional statements in programming. Yep, that's one. Okay. What are some of the other reasons that this might come in handy or useful?
Just maybe building off that, it can affect the end result. So depending on what your end results are, you want to make sure that you get the wording correct as to how you're using it.
Yeah, because sometimes you're not only writing your own program. In other words, if somebody else is writing a program and you're reading the code of somebody else, you kind of have to know, okay, that person is writing it using this particular way. Is it the same as this, my understanding, or is it only implying what I'm understanding, or is it implied by what I'm understanding what it is? Because now, if they're not truly equivalent, then they're not exactly the same. So it's really kind of important to understand what implies what and not exactly equivalent. Okay. All right. Well, this does bring us back to the conditional statement that we have been dealing all along. In other words, when we use this statement here, if x is greater than y, then z gets x, else. Okay, let me just look at this part here. Okay. If the statement is only this part, okay, without the else portion, using the understanding of the word if in this context, what does it say when x is less than or equal to 1? Does it say anything about that? Because if we apply what we have just talked about, this means x is greater than y is a sufficient condition to perform this operation. Are we doing okay so far? Because we're just borrowing from what we just talked about. X is greater than y is a sufficient condition to perform the operation of z gets x. Does it say anything about what happens when x is less than or equal to y? Not a single thing. So that means if x is less than or equal to y, we can choose to do this too, according to the definition of the word if. And this is a big thing in programming, because ever since the first day that people put a conditional statement into a high-level programming language, they have been using it incorrectly. This should not be the word if, because it should have been the word, it should have been what? Okay, what do you think is the meaning of this statement? If x is less than or equal to y, what am I supposed to do? Not to perform z gets x, right? I mean, that's how we understand this statement. Is this is if this x is greater than y being true is the sufficient and necessary condition in order to perform the operation, copying the value of x to z. So that means when we write something like this in a program, what we really mean is if and only if. Okay? But by convention, we only use the word if. But it really means if and only if. Are we still doing okay so far? Yep.
So, in that statement, if it was if and only if, it should have like had what is it, like two? It was just if it would have just said like the one statement and then not the both. So it had if and only, then you'd have to do the both statement.
Well, if and only if means, if x is not greater than y, then we should not perform this operation. If and only if it guarantees that. But if you just use the word if, it does not guarantee, it doesn't tell you what to do when the condition is false.
Like using like else, is that?
Now, when you add the else to the whole thing, then it makes it slightly more clear.
Okay.
Because now it says, okay, there's an alternative when the condition is not true. But without the else, it is actually somewhat ambiguous. What am I supposed to do when the condition is not true? According to the definition of the word if, it doesn't say a single thing. You can't go ahead and perform that operation anyway. Okay, and that's why it really should be more clear and say if and only if, and not just use the word if. There was another hand. Go ahead.
Is there a language that uses if and only if like that?
Nope, none that I know. That's because computer science is broken up into basically two camps. At least the way I understand it is it's broken up into two camps. The pragmatic side are the programmers, the coders. Okay, they use math as whenever it's necessary, but otherwise they just kind of do things to make a program work, to make computers work basically. The other camp are mathematicians. Okay, and they look at everything from the view of mathematics. So the people who invented programming languages, guess which camp they came from? The pragmatic side, right? So they just use the word if in a more kind of looser definition, and they just say, okay, if as a word is good enough. We don't have to use if and only if. But I just want to point that out, that it should be if and only if and not if in this context. Right, so how do we get that out of the way? We are done with the control structures of programming. Okay, so there are only 5 or 6 things that we have talked about so far, and that really forms the most core basis of programming. Okay, the first thing we talked about was the concept of a variable. Okay, I just want to kind of recount the things that we talked about so far. A variable is a place where you can store a value. What you can do with a variable is you can read the value. You can say, hey, variable x, what is your current value? You can also store a value into a variable using an assignment statement. If you specify a variable on the left-hand side of an assignment operation, then it will be updated by the expression on the right-hand side. Okay, that's the first thing we talked about, variables. The second thing we talked about is the concept of a sequence. Okay, if you specify a sequence of statements, then they will execute in the order that you specify from top to bottom. That's going to be quite boring, so we added conditional statements. A conditional statement is a mechanism where you can go down, and then at one point there will be a condition to evaluate. Depending on the result of the condition, you can choose one path or the other path. But the two paths will eventually merge and continue execution. In other words, conditional statements do not give you the ability to do something over and over again. And then on top of that, we added the pre-checking loop and the post-checking loop, where you now have a mechanism of going back to perform a step over and over again. So these constructs, so we have 2 loops, conditional statement, a sequence, and assignment statements. So these 5 basic elements of programming is the core part of just about any programming language that you can encounter. Okay? Wow. So we are almost done, and this is just what, the 3rd or 4th week of the semester. What are we going to do with the other weeks of this semester? Well, there's plenty of stuff that we have to do. Plenty. So don't worry, we are not going to run out of material. Yep.
10 minutes.
Sorry?
10 minutes.
Oh, roll sheet. Thank you. Thank you for the reminder. Okay, there we go. Okay, so what we'll do is now we'll start to get into the concept of nesting. Okay, so I want to show you where we are at this point. We are still in topic 2, and we are moving on to nested statements at this point. Okay, so we'll talk about nested statements. Now, before we talk about nested statements, or basically what it is and how do we use nested statements and all the other stuff, all the details, the first question is why? Why do we need nested statements? Well, what do you think? Well, let me give you an analogy of without nested statements. What is the largest hard drive you can buy at Fry's these days? If I give you $100, okay, how many terabytes can I buy? 2 to 3 terabytes, right? I think 4 terabyte drives are now starting to emerge, but it's not inexpensive yet. Okay, so 3 terabyte hard drive. Now that's really insane because who needs more than 1 terabyte? I mean, I have half a terabyte of storage on my desktop computer, and I have only filled it up to maybe 200 or so gigabytes, a fraction of that. And I run virtual machines. I have one XP virtual machine, one Windows 7 virtual machine, and stuff like that. And I still cannot fill up even 500 gigabytes, which is half a terabyte. Okay, so that's kind of besides the point. Okay, so let's say you have a 2 terabyte hard drive, and I will say I'll give it to you for free even, but there's one catch: you cannot have subfolders on that drive. Okay, does everybody understand what is a subfolder?
Yes.
Okay, so if I say you have a 2 terabyte hard drive, but the restriction is you cannot have subfolders, how useful is that drive?
Useless.
It's not very useful. You can still use it, as far as you can keep track of files in a single folder, right? So if you use the 2 terabyte hard drive to back up your 1 terabyte hard drive, maybe it's still useful because it will create one single archive file for each 1 terabyte hard drive. So you only have one file in the folder. It will still be useful for that purpose. But if you want to use that drive to store all the digital pictures that you have ever taken using everything from your 2 or 1.3 megapixel camera all the way back to every picture that you take these days with your phone, how many pictures do you think you have taken?
Thousands.
Probably at least tens of thousands, right? Well, a 2 terabyte hard drive can easily fit 20, 30, 50,000 pictures, okay, even at high resolution. The question is, can you find the picture that you want when you have all of those pictures in the same folder? Not easily, okay? It can be done. It might take a few days, but it can be done. It's just not easily. So that kind of explains why we have the concept of subfolders. Okay, so remind me again, why do we have subfolders when it comes to storing files on a hard drive?
Organizing.
For organizing, very good. Okay, so you can you can actually locate things a little bit quicker, right? Okay, and it's the same reason why we have nested statements. Why one statement can contain other statements. Okay, because if we do not have the ability of having one statement to contain other statements, you will have a hard time specifying the logic of a program. Not impossible, but very hard, and your program will not be structured. What is the title of CISP360? Because most of you are taking this class to fulfill a prerequisite to CISP360. What is the title of CISP360? The official title, not just C++ programming, but it has a particular word that is important. Okay, let's take a look. Okay, so we'll go to CISP360 ARC. I'm lazy. Sorry?
Is it object-oriented?
It's not object-oriented. That's actually not the focus. Okay, if I go to CISP360, it's Introduction to Structured Programming. Okay, it is that structured is the key of why we need nested statements. because it allows us to build something that is structured. Okay? When you look at a folder and a subfolder and subfolder and subfolder, that is a structure. Okay? It is quote unquote kind of like a skeleton. It gives you, structure. Structure programming is the same way. Okay? We need to have the ability to put a particular statement inside another statement in order to have structure. Okay? So that's why we have nested statements. So let's go ahead and take a look at what exactly is a nested statement. Well, we have already encountered those concepts already just today. This is already a nested statement. In other words, it is a statement by itself. It's called a pre-checking look. A pre-checking look is a statement. It spans over 3 lines in this case. But there's another statement inside this statement. There's a nested statement in this case. Can anyone point out the line number and also the type of the statement that is nested within the while?
3.
Okay, line 3
statement.
is an assignment statement. So in this case, we have an assignment statement on line 3 that is nested within the while statement, which is from line 2 to line 4. Are we doing okay so far with this concept of nesting? Okay. Remember that problem that we had earlier, trying to find the maximum of 3 variables? I can solve that problem without using the conjunction, disjunction, or negation operator, but instead I can use structured. Okay, I can use a structure of conditional statements to do it. Okay, before I write the code, what I'll do is I'm going to use the whiteboard to talk about it. Okay, so if you look at a conditional statement, it looks like this. Okay, it has a condition to evaluate, and then you have to choose one of the 2 branches. Is that right? Okay. We have 3 variables, so you cannot compare all 3 variables using a condition without using conjunction, disjunction, or negation. Because you can only compare one to the other. You cannot say, x is less than y, which is also less than, z. It doesn't work. Okay, I'll take it the way it is. I'll just compare 2. Is that okay? Did I use conjunction or disjunction? Nope. Okay, simple comparison. So one side is labeled true, the other side is labeled false. Okay, let's look at the side that is labeled true. And my job is to find the maximum of all 3 variables. If w is confirmed to be less than x, can w be the maximum? Nope, it's not possible, right? Because I have just ruled out w being the maximum. So when I am here, okay, now this is the conditional statement of what I need to do when w is less than x. And I intentionally make this block really huge because I want to put something kind of more complicated into this part. And the same thing of this part here. I'm making this block kind of big because I have something that is a little bit more complex to put in there as well. Am I still doing okay so far with this picture? How would you call this type of statement? It's a conditional statement, also known as an if statement. Okay? Is this one if statement or is this multiple if statement? So far, of what I have drawn so far on the whiteboard, it's one single one, right? If blah blah blah, then this, else that. Okay, that's a single conditional statement. Well, with what we're talking about right now, I can have another conditional statement contained entirely within the then branch of one side and entirely contained within the else branch of the other block. Okay, so now the question is, if I ever get to this part here, out of the true branch, I know that w is less than x already. So how do I find the maximum of the 3 variables? Wait, I don't have 3 to consider anymore, do I? I only got 2 to consider now because w is now ruled out as the maximum. So that means now I can just focus on x and y. Is that making any sense? So now I can say, all right, let's do another branch here. But this time I'm just comparing x versus y. Yep.
What if you do an x less than or equal to y, or?
It's okay. This will handle that too. So now we have another conditional statement you can see the shape of a conditional statement stays exactly the same whether it is the outer one or the inner one. Is that making any sense? Okay. So if x is less than y as the inner conditional statement, true branch, false branch, that means y is going to be the maximum of the three. Is that making any sense? Because I won't get here unless w is already less than x. And I won't get here unless x is also less than y. So that means by the time I get here, I know that y is greater than x and x is greater than w. So I can say, hey, I know for sure that y is the maximum in this case, store it into z, and I'm all done. Is that all right? Okay. Now on the other side, what am I going to do? Well, on this side, what it means is w is still ruled out because otherwise I wouldn't be on this side. But in this case, it's saying x is greater than or equal to y. Now, if x is greater than or equal to y, I can just take x as the maximum. Even if x and y are exactly the same, it's okay, because if they are exactly the same, I can just pick one or the other. Doesn't matter which one I pick. So in this case, I can safely say that if I copy the value of x into z, z becomes the maximum of the three. Is that making any sense? What about the other side? What about the else side of the outer conditional statement?
You will have X.
So in this case, we know that w is greater than or equal to x. It can still be equal to, but if w is equal to x, then I can just use w for all considerations because they are exactly the same. So that means I can just say, okay, forget about x, because I just need to worry about w in this case. Is that making any sense? Okay. So now I only have w versus y, to compare, and I'm going to use less than to compare. You can use less than or equal to. It will just, it will still work just fine. Okay. So now I have, once again, a branch that is marked true, a branch that is marked false, and this one is also a conditional statement, because all I'm doing is to say, okay, I'm going to ask this question, and depending on whether it is true or false, I'll go one way or the other. Okay? If I get here, that means w is greater than or equal to x, so I only have to worry about w. If I get here, that means w is less than y, and that means y is going to be the maximum. Right? Any questions about this one? What about the other one? I think that's fairly clear because we have three variables, w, x, and y. We have taken all the considerations when x and y can be the maximum, and this one has to be taken care of. W. Yep, because we only have one left. It has to be the one that handles the case when w is the maximum. Well, in this case, w is guaranteed to be greater than or equal to y. But that's okay, because if they are exactly the same, both are the maximum, and I can just pick one, to copy to z. And there we have it. Okay, this is the other way to find the maximum of three variables, w, x, and y. Instead of using conjunction, which is what we used earlier, and a multi-branch conditional statement, we can stick with the simplest kind of conditional statement, but instead we can use nested statements to accomplish the same result. Are we doing okay so far with this picture? Now for those of you who want to say, well, I'm not quite sure I can remember this picture, you're more than welcome to use your cell phone to take a picture of this. Okay. I'm not going to do that, just because I know you guys have better phones than I do, so. Go ahead.
Are you still going to keep going with this, or are you going to go over the homework?
The homework.
Like that?
Oh, the homework that's due today. Yes, we'll have to go over that.
Oh.
Yep, thank you. So I'm going to leave this one up on the whiteboard for people who want to take a picture, and we'll go back and do the homework. I forgot about the homework. The homework is the conditional statement. Oh, how appropriate. Right? That's exactly, what we are doing here. And we got 10 minutes to do it. I think we got enough time. All All right, so here we have the pseudocode of your homework assignment. And we'll go through all the traces related. I just did something not so smart, did I? Yeah, I closed. I closed the one that I wanted to open. That's okay. And we go to sheet 2. All right, so we start execution on line 1. X is less than Y is true. Then we go to line 2 because we go to the then branch in this case. We copy X to Z. Z gets the value. Oops, Z gets the value of 2, and then we are all done. Get to post. Okay. We move on to sheet 3. Same thing. On line 1, we have to evaluate the condition, but this time the condition evaluates to false. So that means we have to go to the else branch, which is on line 4. On line 4, we copy the value of Y, which is 2, to Z. So Z ends up with a value of 2. And after that, we have nothing to do. Post. And this is sheet 4. On sheet 4, we do the same thing. X is less than Y is the condition that we have to evaluate on line 1. And that is false. That is also false because 2 is less than 2 is false. So that means it's going to follow the same flow as the previous trace on sheet 3. We are going to line 4 to continue execution. In this case, we also copy the value of Y, which is 2, to Z. Z gets a value of 2, and then we are done. Post. So that's the solution of the homework assignment. Took me what?
30 seconds.
3 minutes. But are there any questions about this? Just because I can go through it, really quickly, it doesn't mean that there may not be questions about it. Are there any questions about this homework assignment? No questions? Okay, but we still have 7 minutes remaining. So with 7 minutes remaining, I can code this picture into pseudocode. Okay, so we'll go ahead and write this in pseudocode. And I will do it in 2 ways. Okay. The first way to do it, I'm going to do it in a just a regular editor, and then I'll do it inside the spreadsheet if I have enough time. Okay. So the question now is, how am I going to code something like this, knowing that the logic I want to represent is basically 3 conditional statements. Now, what 3 conditional statements? Where do we find 3 conditional statements? One is the outer one that is containing the other 2, and then so the outer one is 1. This part here is another one. This part here is the last one. So we have 3 conditional statements where 1 is containing the other 2. Okay. So the way I write programs is kind of funny. The way I do it is like this. Okay. This is the shell of the outer one, and then what I do is I'm going to do exactly the same thing with the inner one, and then the other inner one. In other words, I do not write my program in a linear fashion. I write my programs in a structured way. Okay. In other words, I give the entire structure of the outer conditional statement first without filling in anything, and then I move in and give the structure of the then branch conditional statement, and then I give the structure to the else branch conditional statement. In other words, what I'm doing here is I'm creating a folder structure. I'm saying, okay, these are the pictures for 2014, and now I'm creating subfolders for each month without actually moving any pictures just yet. Am I making any sense? Now, if I do it like this, I would not have a chance to forget to end the if. I would not have a chance to forget the else, or closing a close parenthesis, because I open and close it right away. Okay. And of course, now we can fill in the details. So according to the picture, the outer conditional statement has a condition of W is less than X. The inner one has a condition of X is less than Y. And then the other side will compare W versus Y. And then over here, we confirm that Y is the maximum. And over here, we confirm that X is the maximum. Here, we confirm Y is the maximum again. And here we confirm that W is the maximum. And there we have the nested conditional statement. Are there any questions about the process, that I use to look at the logic I want to represent and then go back and specify the pseudocode? Go ahead.
Just really quick, after the first one, if it's false, then you just skip all the way to the else in the middle.
Okay, let me give these line numbers so I can refer to the line number. Just hold it 1 second. Go ahead.
So if 41 is false, then
Then I go to line 48.
48.
48 is corresponding to this part of the picture.
So basically, when you write that, you work from the outside in.
Correct. I create the structure from the outside in. Yep. Go ahead.
If it's true, then at 46.
If what is true?
If 41 is true, then.
If the condition of line 41 is true, we continue execution on line 42. Line 42 represents the beginning of the embedded conditional statement starting on line 42, ending on line 46. Okay? So, is that okay with you?
Yeah.
Okay. Okay, so this is also the part when I can also explain why indentation is important, because this is the one with indentation. I'm going to copy and paste this so that it is not, it has no indentation anymore. Okay, so I'm going to copy and paste it and remove all the indentations. In other words, it has no indication using indentation as to how things are structured. Okay.
It's confusing.
It gets a little bit harder to read, doesn't it? Because now you really have to scan through the program. Let's say you are on line 58. Okay, let's say you're done with line 58. So now your question is, where am I supposed to go? It's a little bit harder to figure out because first of all, you have to figure out, okay, the next line is else. That means it's the end of this particular branch. Okay, but this is a branch of a conditional statement. Where is the end of the conditional statement that you're in at this point? Well, you're supposed to find the end if, right? So you have to scan through the code to find the end if corresponding to this code here, which is on line 61. So now you're on line 61, and then you have to figure out, okay, we are now at the end of a conditional statement. Is there anything else for me to do with this branch from the outer conditional statements perspective? And then you encounter the next word, which is else, which means, nope, there's nothing else to do. And then you have to try to find the end if corresponding to the else of line 62. Now, how do you find the end if corresponding to the else of line 62? Well, the next line is an if, right? So as you linearly scan through the whole thing, you have to say, okay, I'm on line 62, I need to go find the end if corresponding to this else. The next line is an if, which is the equivalent to another open parenthesis. So you have to say, okay, I have to find the end of this if first, because it is the embedded conditional statement. So you go to, oh, okay, line 67 is closing the if of line 63. So now I can try to find my own end if, which is the next line. But it is a lot more involved compared to the previous case where we have indentation. Because when you have indentation, you can basically use that to line up, and it represents the structure of the program in a much more visual way. Do you think the compiler or a programming language cares about the indentation or the empty spaces before, on the left-hand side of a line? Most do not, and only Python cares. Okay? In Python, that's the only way to specify nesting. But in all other programming languages, including C and C++, in cisp300, the compiler does not care. You can write the entire program on a single line, and it's okay with the compiler. The question is it okay with you? Can you read your own program and understand what is going on to debug your own program? That really is the question. Okay, so the indentation is here not to help the compiler, with the exception of Python. It is really here to aid you as a person reading the program. Okay, So that's the end of today's lecture. There's no new homework assignment, but there's already one due on Tuesday. So you have to make sure that you remember to do that one.
Question on this one here.
Okay, just hold on a second. Let me turn off the recorder.